Okay, if you got cut off during today's video Zoom call, we had some technical issues, so here's just a reload of the lesson. This was our assignment. Go and click it, open it, find it. But basically, we're just taking derivative graphs again today, and we're making some claims about the original graph, which we can't see. So basically, somebody came in, took our original function, plotted all of the derivatives of it, and connected them to make a new function. One thing that's going to be extremely invaluable for you today is going to be to have your chart in front of you, your note sheet, that helps you convert back and forth. So this is going to be huge. If you don't have these notes, take a screenshot of this video right now and copy these down and have these with you. Live by these during this lesson and anytime we have to go back and forth here. So one column kind of tells us, like, if our original, our f graph looks like this, our derivative graph is going to look like this. And I have some annotations that kind of help us make sense of what specifically this looks like. So with that being said, let's go to the very first question. So it says find the relative max of f of x. All right, so let's look at our chart. Relative max of f of x right here. That's our original function f. If there's a max there, what does that look like on our derivative graph here? Well, we'll be looking for where the derivative is 0. So think about where your outputs are 0. That's going to be on the x-axis. And we know that a maximum changes from increasing to decreasing, so it's going to change, the derivative is going to change, the slope is going to change from positive to negative. What that's going to look like is it's going to go from above, right, all the positive y values to below all the negative y values. So quick annotation here would be this. F prime would be equal to 0, and it goes from above to below the axis. So let's just kind of look. We have f prime values of 0 here, here, and here, right? So if I wanted to kind of mark those as like a check, I don't know that all three of those are maximums because it has to go from above to below. Positive to negative. So let's see here. This one, if I read this from left to right, goes from the negative to the positive. All right, so that's not correct. This one here goes from positive and bounces back to positive. This one here goes from positive to negative here, above to below. And then lastly, this one, I forgot to check, goes from negative to negative. So that one's not correct either. So the only relative max that we're going to have here is x equals 6 because of those characteristics. Now we're going to find the x-coordinates of any inflection points. Now, inflection points, there are two things that you have to remember, which are, I'm going to actually add on here. The derivative of the derivative, f double prime, has to be equal to 0. So it has to be differentiable. And it has to be a local min or a max on there, right? That's where it's going to kind of concave up or concave down and get that max or min, that horizontal tangent. Now, even though that there are max and mins on here, and we might be thinking those are inflection points, where it changes concavity, right? It goes from increasing, which is concave up, to decreasing, which is concave down. We may think of these as inflection points, but the problem with these is that their double prime value, we can't differentiate that. It's not equal to 0. All of these are corners, and corners are not differentiable. So in a twist here, we might think that these are inflection points where it changes concave up and concave down. It does, but in order to truly be an inflection point, these need to be rounded where we would actually have a horizontal tangent. So it would have to look like this. That would be a derivative of 0, as opposed to this. That's going to be ND for non-differentiable. So in this case, x-coordinates of inflection points, there are none. Okay, and that's kind of a tricky one, but we just don't have any points of inflection. The critical points of f of x. All right, so now this is kind of a definition that we have to go back and find. Critical points are going to be any max or min. Okay, those are critical points, and any undefined slopes. So critical points, just so that we remember, is going to be anytime f prime equals 0. So we're just looking for any time, basically, we get a horizontal tangent. So it's going to be 1, 2, 3, 4 different places. So that's going to be at x equals -2, x equals 2, x equals 6, and x equals 10. all of those have derivatives of 0. All right, and then I did skip number 3, oops. F of x is decreasing. So let's go back and let's look at this chart again. Let's find where f is decreasing. Okay, what does f prime look like? F prime is going to be negative, and I wrote a note to myself. That means below the x-axis. That's where all those negatives are. So all we have to do for this is find where f prime is below the axis. That's going to be all of these sections here, from here to here, from here to here, and from here to here. Now in this one, we're going to have to write this as an interval because it's including many points. So remember that we only use x values from -4 to -2. And then we're going to go from 6 to 10. And notice how we're not including 10 because technically when it gets to 10, it's not negative, right? It's actually 0. So we can't include that. That's why we're not going to use a square bracket there. And then we're going to say from 10 to 12. Okay, so that's going to be where it's decreasing. And once again, I look to find actually where f prime was below the axis. And then the last one, to find out where f of x, the original graph, is concave up. So if f is concave up, we'd actually be looking for where f prime, the slope, is increasing. So when the slope is going up, so where f prime is going up. So all we have to do is look to see if we can find some increasing sections of our graph. So let me just make a quick note. F prime is increasing. So this actually means now it has to be going up. So it looks like all in here, from here to here, it's going up. So that section would be from -4 to 0. Notice how I use just the x values, -4 to 0 there, to write my interval. Where else is it increasing? Okay, here to here, which is from 2 to 4. Then it decreases again, decreases, and then it increases again right here. And remember, we're just using the x values, 8 to 10. Okay, so this is how I would read my graphs. This is how I would use this reference sheet to kind of help me. And then for you guys, there's one more thing that you would have to do, which is this page right here, where you actually have to justify. Now, some sentence frames that I would really recommend you using is you're trying to find and characterize what's happening on f, our original function, and you're going to justify it by what's happening with our f prime graph right here. So I would say things like f is blank because f prime blank, right? Or f has, something because f prime, okay? So we're going to be using this because f prime as our justification for what f is doing. So we have to find where f has a relative max in this problem. So if I once again look to see where f has a relative max, that means my derivative is 0. All right, so f prime is going to be on the x-axis, and it's going to change from above to below. So f prime is going to be on axis. This is my annotation, and I'm looking for above to below. I might be a little bit more careful with my justification, but let me just find it first. So f prime is on the axis here, 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 and here. And we have to change from above to below, positive to negative. So we change from positive to negative here, perfect. This goes from negative to positive, and this goes from positive to negative here. So we actually have two relative maxes. We have one at x equals -3 and x equals 4. And I'm just going to kind of write them out to the side for myself, and now I'm going to justify using one of these sentence frames. So I'm going to say f has a relative max at x equals -3 and x equals 4 because, and now I'm going to actually justify this with what f prime is doing. Because what is happening at f prime at those points? Because f prime is 0 at x equals -3 and x equals 4. And what else do I know about it? And f prime does what? Changes from positive to negative. At those points. Okay, so this would be kind of like my AP answer. All right, I'm using a sentence frame that I've given you, and I've really made sure to kind of spell out as much as I could. In this case, I had to say and this because remember that f prime, it's not enough just for it to have a derivative of 0. It also has to change from positive to negative. And that's really important when we're talking about a derivative and justifying our answer thoroughly. So I hope this clarified some things. If you missed the Zoom call today, here you go. If you're in the Zoom call today but you wanted a second look, here it is. I hope this was clear, concise, and you feel comfortable. So your homework tonight is really just to finish this, talk about where it has inflection points and where it is concave up and increasing. Okay, so think about solving these two problems separately and then seeing where do those answers overlap and what answers are kind of, do they have in common. So good luck and see you later.